Alright, we're going to talk about electron volts. So an electron volt is a unit. We use it to measure energies. So just like how we can measure distances in centimeters or in inches, and either way it's still a distance, we can measure energies in joules or in this new unit called an electron volt. And typically you would use an electron volt if you're working with very small amounts of energy, which we often are in this unit. So the conversion factor is that 1 electron volt is 1.6 times 10 to the negative 19 joules. And you might be thinking that that 1.6 times 10 to the negative 19 number looks familiar. And the reason it looks familiar is because of the definition. So 1 electron volt is defined as the amount of energy that an electron loses or gains when it passes through an electric potential difference of 1 volt. So remember we have this formula here. Delta V is the change in energy over the charge. If we rearrange for change in energy, we get change in energy is the electric potential difference times the charge. If we go ahead and we put in here 1 volt for the electric potential difference and the charge on an electron, which is 1.6 times 10 to the negative 19 coulombs for the charge, whatever this number is equal to, that has to be 1 electron volt, because that's how 1 electron volt is defined. So 1 times 1.6 times 10 to the negative 19 is just still 1.6 times 10 to the negative 19. But look at the units. So remember, a volt is the same thing as a joule per coulomb, and we're multiplying that by a coulomb. So coulombs cancel, and that gives us joules. But remember we said that amount of energy is also 1 electron volt. So that's where the conversion comes from. So let's see how to use this by doing example 5. So a charge of 3.2 times 10 to the negative 19 coulombs is moved from a location with an electric potential of 2,000 volts to another location with an electric potential of 3,000 volts. Determine part A, the potential difference between the two positions. So we're just finding delta V. So we're just going to do 3,000 volts minus 2,000 volts. And we find a difference of 1,000 volts. And then in part B, we want to find the electric potential energy gained by moving the charge in both joules and electron volts. So let's take our formula that we had up here and let's use it again. So delta E is delta V times Q. So we're going to have the potential difference, which was 1,000 volts, times the charge given in the question, which was 3.2 times 10 to the negative 19 coulombs. And when we do that, we're going to get 3.2 times 10 to the negative 16 joules. Now, we have to convert that to electron volts because the question asks us to give this energy in terms of both units. So we're going to just write down that number again. So 3.2 times 10 to the negative 16 joules. And we'll do our conversion. So in every 1 electron volt, there's 1.60 times 10 to the negative 19 joules. So joules now cancels out. Now when I put this in my calculator, I really just typed in 3.2 times 10 to the negative 16 divided by 1.6 times 10 to the negative 19, because that's the same thing as multiplying by 1 over that number. And this gave me 2,000 electron volts. And if I round that just to have the right number of significant digits, that's going to be 2 times 10 to the 3 electron volts.